Hey guys, Tomatho here. Here is a challenging Olympiad questions on algebra. And I guarantee only secondary school knowledge required. So here is the problem. Given an equation, 9 to the power of x plus 12 to the power of x equals to 16 to the power of x, where x is a real number. Can you solve the value of x? Pause the video if you would like to give this question a try and continue watching to know the solution. From the original equation, you may be very confused. How do we even start? Let me give you some simple trick. Let's divide both sides by 9 to the power of x, and this equation becomes 1 plus 12 over 9 to the power of x equals to 16 over 9 to the power of x. And since 12 over 9 can be simplified as 4 over 3, then we can rewrite it as follows. Since 16 over 9 equals to 4 over 3 square, we have 1 plus 4 over 3 to the power of x equals to 4 over 3 square to the power of x. Recall the property of exponential, where x to the power of a to the power of b equals to x to the power of b to the power of a. So we can swap the 2 and x on the equation. And to make our life simple, we assume y equals 4 over 3 to the power of x. Assume it as a new variable. And the equation becomes 1 plus y equals to y squared. And we rewrite it as y squared minus y minus 1 equals to 0. What equation is this? It is familiar, right? Yes, you are right. It is the quadratic equation. We have reduced the problem to a familiar quadratic equation. To approach this equation, there are two methods that we can use. First is the quadratic formula. If we have ax squared plus bx plus c equals to 0, the roots of the quadratic equation is the following. And here, looking at the corresponding coefficients of our equations, we have a equals 1, b equals minus 1, and c equals minus 1. And plugging this value to the formula, we have the following. And after calculating them, we get y1 equals 1 plus square root of 5 over 2, and y2 equals 1 minus square root of 5 over 2. These two are the roots or solutions of this quadratic equation. Or, if you cannot remember the quadratic formula, there is another method as well, which is completing square. From the original equation, we move minus 1 to the right hand side. Y squared minus y equals to 1. Next, we have to complete the square on the left hand side. As you can see here, the coefficient of y is minus 1. So, to complete the square, we add both sides by minus 1 over 2 square, like what is illustrated here. And on the left hand side, we can rewrite it as y minus half square, right? Then we can just compute on the right hand side, which is 5 over 4. So we have y minus half square equals 5 over 4. And this becomes very simple, as we can take a square root on both sides. Becomes y minus half equals to square root of 5 over 4, which is equals to square root of 5 divided by 2. So the two possible solution to y is half plus square root of 5 over 2 and half minus square root of 5 over 2. With these two methods, we arrive at the same answer for y. Next, going back to our assumption, we know y equals 4 over 3 to the power of x. Okay, we do know that since x is a real number, 4 over 3 to the power of any real number is always a positive number or greater than 0. So y is greater than 0. From the previous results, we know that we have two possible values for y. But since y2 is negative, we must cancel it out and we must take y1. So the only possible value for y is y equals half plus square root of 5 over 2. And since y equals 4 over 3 to the power of x, we can have this equation. And by taking a logarithm of base 4 over 3 on both sides, we finally arrive at the final answer. So yeah, we have finally obtained the value of x. See, we only apply secondary school math concept for this question. Thank you for watching. Give a thumbs up if you like this video and subscribe to my channel if you would like to see more interesting math video.